Alright, so welcome to Chapter 8. This is titled A Strong Acid with a Weak Acid, which will also be similarly approached as a strong base with a weak base. Okay, there's actually no practice problems for you for this. You'll kind of see why at the end what the point is. So let's see, it looks like we're taking nitric acid right here and nitrous acid. Alright, and we're mixing them together. So this isn't a chemical reaction, this is just mixing of two acids, okay? And I can tell that dilution is going to happen because we're taking one volume and mixing it in with another volume. So we'll end up doing a dilution later. So let's talk about major species. So one of the major substances is nitrous acid. Now, that guy is a weak acid. This is going to matter, okay? And then we've got HNO3 is the other guy involved. And this guy is a strong acid. Okay, so here's the interesting part, is two different things happen. HNO2 goes to equilibrium because it's weak. It only slightly ionizes. Okay, while HNO3, it's a weird looking H, sorry, 100% ionizes into H plus and NO3 minus. Okay, so both of these guys will be present. Now, this guy will be present mostly in this form, and the nitric acid will be present mostly in this form. Okay, before we can do anything, we have to do the dilution because they are taking two different acids, you're mixing them together so they will become diluted. So you have to do M1V1, M2V2 twice, once for each acid. So M1 for nitrous acid, 0.2. What's the volume? 50. M2, I don't know. New volume, 50 plus 150 is 200. Okay? So the nitrous acid is, let's see if you calculate that out, I think it ends up being 0.050 molar nitrous acid. Ooh, easy. I put a 3 there, HNO2. Okay, now you have to do this all over again, but for the nitric acid right here. So molarity, 0.6. I think I used these numbers on a different problem. So 150 is the volume, M1, V1, M2, I don't know, V2, 200. So the molarity of the nitric acid is 0.45 molar, HNO3. Okay. Here we go. Now, we will have an equilibrium expression for one of these. It will be for the weak one. Here's why. Weak substances go to equilibrium. So my equilibrium expression is going to look like this. Ka. I call it A because this guy is an acid, right? Equals products over reactants raised to their respective coefficients, which all of these are 1. And all of these are aqueous, so they all get written in here. Okay? And K is given, right? So K was given. Ka of the nitrous acid. So all of this is going to equal 5.1 times 10 to the -4th. Right? So here's my equilibrium expression with my Ka value. Okay? And I only write it for my weak acid. Strong acid is irrelevant right now. Alright? Okay, now let me go up to a new page. Okay? Whenever you actually do have an equilibrium expression, you will end up setting up an ice chart. Alright? And the ice chart is set up for the weak substance. Okay? So ICE. Now, what is the concentration after dilution? So I'm not looking for this 0.2 molar. I want to know what it is after I've mixed it. And if you go back, I think it was 0.050 molar. Okay? Now, here's where you have to be careful. Usually we instantly go and throw 0, 0 here. Alright? Because you say initially you don't have any of this and any of this. That is true if all that is in there is HNO2. But that's not all that's in there. Isn't nitric acid in there? There is, and the nitric acid after dilution is 0.45 molar. What does that mean? That means it's 0.45 molar. Whoa, sorry. 0.45 molar nitrate. Ooh, check that off the list. Okay, and it also means 0.45 molar H+. So the initial concentration of H+ is an actual number this time because there is a source of hydrogen ions coming from the nitric acid. However, the nitrate's still 0. Okay? Question so far. All right, now what do we always do? Let me change my color. Okay, so we let X equal the concentration I'm going to do of the one I don't have any of, and it'll make your life easier, of nitrate. Sorry, nitrite. At equilibrium. Right? So this is X. So this must be plus X. This must also be plus X because it's a 1-to-1 ratio. This is going to be minus X because it's a reactant and it reacts. So what do we have at equilibrium? We have 0.5050 minus X. We have 0.45 plus X, and we have X. Okay? Whenever you have these, you will always do the next step, which is plugging into the equilibrium expression. So I'm going to change my color again. My equilibrium expression, was 5.1 times 10 to the -4th equals products. So 0.45 plus X, there's one of my products. There's my other product, X, okay, over 0.050 minus X, so my reactants, okay? And now what do? How do we make life easier? Let's change my color again. Ooh, this one's really colorful. I like this one. Assume X is much smaller. And then, who are you going to pick? Do you want it to be smaller than 0.45 or do you want it to be smaller than 0.05? Well, if you pick that it's smaller than the smaller one, 0.05, then it's definitely smaller than 0.45. So we're going to pick the smaller of the two. Okay? What does that allow us to do? Any x's that are being subtracted now we can consider negligible. So bye-bye. Bye-bye. Right? So then what do? Solve for x. This is easy rearrangement. You multiply both sides by 0.5, okay? And then you divide both sides by 0.45, and x comes out to be 5.7 times 10 to the -5th molar. Now, well, who is x? That's nitrite, right? So I just took care of the concentration of that guy. Okay. All right. How much HNO3? We haven't really answered that. Should you have at the end? Well, because it's a strong acid, you shouldn't have any of it. It should 100% ionize. Is that right? Okay. What about HNO2? Well, HNO2 was 0.050 minus X. So you take 0.050 and you subtract this number. And even after rounding, I'm pretty sure you get 0.050 molar HNO2. It changes it slightly, but with sig figs, I think you end up with 0.050. Okay? So my HNO2 is done. Okay, what about my H+? Well, my H+ is defined as 0.45 plus X. So it is 0.45 plus 5.7 times 10 to the -5th. And if you plug that in your calculator, which I'm doing really quick, you get 0.45 molar H+. So check. Okay. All right. here is the main point of this. After this, it's all downhill. You can get pH, POH, OH minus. I might run out of room, but I'll do my best to write small. The point of this slide is when you have a strong acid with a weak acid, or a strong base with the weak base, the pH, or the POH, if it is a base, is solely dependent on the strong substance. Look at 0.45 molar came from the nitric acid. The weak substance contributes such a small amount that the pH really pretty much comes from the strong acid and or strong base. Okay, so let's finish this problem out. How do you find pH? Well, pH is opposite the log of H, so opposite the log of 0.45. I haven't done this yet. I guess I should do that. Opposite the log of 0.45 is 0.35. It's 2 sig figs, right? Okay, so what is POH? Well, POH is 14 minus 0.35. So 14 minus 0.35 is 13.65 POH. Oops, excuse me, sorry. Okay, so I got pH, I got POH. Now I need to get the OH minus. So the easiest way to do this, in my opinion, is the K equation. H plus times OH minus is 1 times 10 to the negative 14. The H plus was 0.45. So you put in 0.45 here. Okay? And then X for your OH minus. Oops. I'm going to erase that. Sorry. 1 times 10 to the negative 14. So 1 times 10 to the negative 14 divided by 0.45 OH minus is 2.2. Sorry, I'm running out of room. Times 10 to the negative 14th. 14 molar. Okay? So the question is the solution acidic, basic, or neutral? Well, the pH is 0.35. That is a very, very acidic pH, which should make sense because the nitric acid is an acid, and the nitrous acid is an acid, and all you have in there is acid. So it should make sense that your pH is something in the acidic range. And again, the main point of this is that the main source of the contribution of hydrogen ions comes from the strong acid. The weak acid barely changes that at all, okay? So the pH is almost purely dependent on the strong acid and not even on the weak acid at all. And that is it for Chapter 8.